When I first started creating these videos, I didn't plan on having a video to cover the topic, what is functional programming? But then I realized that if I was watching these videos, I'd want to see at least some definition of that early on in a training course. So that's why I created this particular video. And this one comes from my book, Functional Programming Simplified. And this is actually a really interesting discussion because it's hard to find a consistent definition of functional programming. And I was really surprised about this back in 2015. I think some of that depends on everyone's level of experience when they're trying to define it, because as I note here, some people will talk about pure functions, and I think that's a really good start. But then they'll add something else and they'll say, well, their programming language must be lazy, which means lazily evaluated. So when I was first learning functional programming, that really threw me off. Does a language really have to be lazy to be functional? And the short answer for me is no, it doesn't have to be. And I'll get back to that in a few moments. After thinking about this for quite some time, I think you can define functional programming with just two statements. The first one is that functional programming is about writing software applications using only pure functions. I talked about pure functions in a previous lesson, so I won't get into that too much again here, but I will jump back to my other book real quick and just say that if you're interested, and if you haven't watched the previous video on pure functions, I defined those in these statements right here. And you can see from this that it's harder to define pure functions than it is to define functional programming. So if you didn't watch that video yet, either watch it or go ahead and read the definitions now before I move on. So using only pure functions is the first part of my definition. Then the second part of the definition is that when you write functional programming code, you only use immutable values, and those are val fields in Scala. And again, I covered this in a previous video on immutable things, and as I note here, a val field just means that it's an immutable variable, or what I call an algebraic variable. And I covered this before in previous videos, so I won't go too in-depth into it here. But when you write algebra, you have equations like this. And in this equation, none of these variables can be mutated. So you don't assign x to this expression here and then come back sometime later and say, well, now what I want to do is reassign x. You just don't do that in algebra. And as a result, we don't do that in functional programming code either. And the way we do that in Scala is we define x to be a val field. So val can't be changed. It's like final in Java, like const in JavaScript, and it's like let in Rust and Swift. So what happens is if you define a val field like this, you'll get an error later if you try to reassign x like that. So again, I won't cover this more now because I covered it in a previous video. The only thing to say is that these variables are immutable. And when you see the term immutable variable, that sounds like a contradiction. And what that means is really that variables are just variables in the algebraic sense that I just showed. And a real key that I note here is that when I say only in these two sentences, I really mean only. You only use pure functions and you only use immutable values, period. So then I combine those two sentences here into one complete sentence. Functional programming is a way of writing software applications using only pure functions and immutable values. And now I want to get into another point here because this wasted a lot of time for me. When I was first learning functional programming, I got a lot of misinformation where people would say, oh, well, a functional programming language must have higher order functions. It must support that. And then they might even include that in the definition. But the reality is it doesn't have to. Higher order functions are like when you pass one function into another, like in a map function that many programming languages support nowadays. So you're passing one function into another. And of course, yeah, sure, that makes functional programming much easier, but it doesn't have to be a part of the definition of functional programming. As I note here, it's just a language feature. It's a terrific language feature, but it's not part of the definition of functional programming. Similarly, I read things like recursion is a requirement of functional programming. And while it is true that functional programming languages definitely use recursion, again, it's a byproduct of how we write code. It doesn't have to be part of the definition. What I mean by that is if you only use pure functions and immutable values, yes, you'll find out that the only way you can do things like calculating the sum of a list is by using recursion. And that's fine, and recursion is wonderful, but it's just a byproduct of my definition. Next in my book, I note here that Wikipedia's definition of FP supports my definition, so I'm not going to go into that. One thing I would like to do is acknowledge Mary Rose Cook because her definitions and her work really helped me out. When I first wrote Functional Programming Simplified, she had been working at the Recurse Center and then at Makers Academy. She wrote this essay called Practical Introduction to Functional Programming, and it really helped me out because she stated everything that I was thinking. She says that people mention all these dizzying number of functional characteristics, and then they try to include those in the definition of functional programming, which to me, that felt wrong. And then she talks about immutable data, first-class functions, tail call optimization. And she was the first one that I read that said these are language features. They'll help you, but they're not necessary. And while I disagree with her on this one particular point, everything else she talks about there and everything she talks about here, these are all language features and these are programming techniques. So again, my point is that a lot of people try to sneak these programming techniques into the definition of functional programming, and I thought that was wrong. And similarly, she says the same thing about these other characteristics here. So she was the first one I ever read that just said, forget about all that stuff, that functional programming is just characterized by one thing, and that's the absence of side effects. And then the sentence right here, she talks about pure functions and says they don't rely on data outside the current function, and they don't change data outside the current function. And every other functional thing for her could be derived from those properties. And I thought that was interesting, really close to my own thinking. And the only thing I added to that myself was the immutable data part. And I think part of this definition can also come from the programming languages that you use. But I really feel like we're in the same ballpark because we come up with this summary here. Functional code is characterized by one thing, the absence of side effects. And as I note right here, to me, that statement means exactly what I wrote at the beginning of this lesson. And that's that functional programming is a way of writing software applications using only pure functions, which have no side effects, and immutable values, which also cannot have any side effects. Immutable values can't be mutated somewhere else in the code. And then in this particular lesson in my book, I go on to talk about immutable values for a while. But since I cover this in my previous lesson on immutable variables, I'm not going to go through this all over again, other than to say that the point I make in that video is that the best functional programming code reads just like algebra. And I want to apologize a little bit there. I got off onto quite a bit of a tangent. And I also want to say that if you want to find the content that I just showed, of course you can read it here on this video, and you can also find free previews of my books on my website, and a lot of this content is also freely available on my website. But the key for this video lesson, and all I really want to summarize with, is just this sentence right here, to say that functional programming is a way of writing software applications using only pure functions and immutable values. So that's my definition, and I'll be proving that in the videos that follow this one, and all the code that we write in this video series.